Hello, in this lesson we're going to see an example of finding the torque of a rod. Okay, so this is a very simple introductory example. Okay, so this pink arrow here is going to be the axis of rotation, and we have a yellow rod. Okay, so because this pink arrow is the axis of rotation, we can see that it will rotate along like this. Okay, so now suppose that I were to apply some kind of force, okay, to a random point, let's say over here. Okay, so this is my force, and remember that it's a vector, okay, so we put an arrow on top. So now we can see that we take our distance, the distance that the force is being applied to from the axis of rotation is r, okay, so we have r until this point, okay, and r, remember, is also a vector quantity. So now we remember that we have our equation for torque, which is tau is equal to our r vector cross our f, okay? Now this triangle is cross, okay, so this also equals this, okay? Alright, so let's see how we do this. Okay, now notice that the angle over here between the radius and the force is going to be 90 degrees. Okay, so now let's see how we work this out. Now, another important thing to remember is that whenever you have r cross f, that the size of this, okay, so if we're going to see the size, because over here the direction is less interesting, but the size of the torque is most interesting. So the size of the torque is equal to the size of our r multiplied by the size of our f, and then sine of the angle, okay? So here, in this case, our theta, okay, because we saw, so our theta is equal to 90 degrees, okay, because we see it's at 90 degrees to the radius, so therefore our tau will equal to, let's write it over here, the size of our tau will equal to the size of our r and the size of our f, okay, because sine theta will therefore be equal to 1, okay, because of this. Okay, so now what we've figured out is the size, okay, so the size of our torque. But now we want to figure out which direction the z-axis will be going in, okay, in which direction our torque is. So how are we going to do this? We're going to be doing this through our right-hand rule. Now, because our force is a vector, we learned earlier on in this course that we can move the arrow anywhere as long as we keep its size and the direction that it's pointing in. Okay, so what I'm going to do is I'm going to move this arrow over to here, okay, keeping the direction.